Is my voice audible?
Yes, it's audible.
Yeah, audible.
Okay. Good evening, everyone. Hope you are sound and safe at home. I, Harshit, convener Csi-Mvsr, take immense pleasure to welcome you all to week of webinar. While we head into a session on Amazon Web Services, I will tell you a few rules that has to be followed by every participant to smooth going of the session. Everyone should mute their microphones. No one should present or cast their screen. No one should turn on their video. No multiple chances to give to join the webinar. Once you quit, you will not be allowed to join again. You can turn your mic only if speaker gives a chance to ask doubts. If any mischief or disturbance is found by any participant, will be removed immediately from the session without prior intimation. All the problems should be messaged to the event coordinator along with a screenshot. Today's coordinator is Lahari. You could find her number in the mail that we have sent to you. Now I request Lahari to brief about the speaker. Thank you.
Respected faculty members, research scholars, today's speaker, and my dear fellow students, I wish you all a very good evening. I am Lahari, Csi-Mvsr Student Coordinator. It gives me a great pleasure to extend a warm welcome to the webinar on Amazon Web Services. I would like to give a brief introduction on today's speaker, Shirisha. Shirisha Kodimala has completed her post-graduation in Information Technology from Indian Institute of Information Technology and Management, Gwalior. Her professional experience include working with legacy applications in re-architecting them using microservices architecture with include latest technology like cloud computing, event-driven architecture. Here are some of the technologies she has hands-on are Spring Boot, React, AWS, etc. Her professional journey include working with companies like ThoughtWorks, Cloud Element, Everest Engineering. Thank you so much, ma'am, for spending your time today. I request today's speaker to continue the session.
Hi everyone, this is Shirisha. So, thank you for introducing me. And we'll start with I'll share my screen and we'll start with today's session. Can everybody see my screen?
Yeah. Yes,
Yeah. Thank you. So today's plan is what is cloud computing and why cloud computing, and then we'll go through we'll follow that will be followed with AWS services, and we'll show the demo after the session, end of the session, which includes how to run EC2 instances and run a sample application over there. Yeah. So is my voice clear? Just to check.
Yes, ma'am, it's clear.
Yeah, okay, thank you. So what is cloud, why cloud computing and what cloud computing? So basically this in 21st century, so most important or most technology which has innovation is like cloud computing and data science. Cloud computing, data science is a field where we'll take summaries from the data which is already stored. But besides that, cloud computing is also a famous technology which got invented in this 21st century or became famous after 2006, after Amazon launched their Amazon Web Services. So why cloud computing is very important and what cloud computing is. So coming to the why part, so because of this, cloud computing architecture. So most of the servers, applications which we run or we use in daily life, they became very cheap to run, to manage, and to use. So that's why it became very, very important innovation this century. So, and what is cloud computing? Coming to the why, what is cloud computing? So just giving the explanation what is cloud computing. It's available to run a server or to run a computer application. We'll need various computer resources. So these resources are available online on demand when we require, without being installed or managed beforehand. So especially the resources, computer resources like storage and computing systems, they are available on demand without, like, let's say I want to run a server or I want to store some of my data. So especially me, I don't want to take care of storing a data in a server or running application and maintaining the server myself. So because that cost of maintaining or storing or purchasing infrastructure for them is a big headache or a costly investment for me. So that's why I don't want to invest my money in those areas of buying infrastructure or managing infrastructure. So that's where I want, as a user, I want these infrastructure or resources available to me as and when I demand or as and when I require. And those resources, like whatever the resources I want to use, those should be scaling up and down based on my needs. Like, let's say I am using 5 GB of storage as of now, but I don't expect my data to be within 3 months of my future, I expect my usage to be 5 GB, and I purchase the data for like storage of 5 GB, but I don't want to invest more money speculating my future. So that's where cloud computing comes in. And while cloud computing is a science which offers various resources in 3 different service models. These are the 3 different service models, like software as a service, platform as a service, and infrastructure as a service. So I'll just go through each of them by showing a example. So on the left side of this one, like traditional IT column, this is application. Like to run every application, these are the stacks which we need, like coming from networking, storage, and servers, and operating system, and the runtimes. Like if you want to run a Java application, Java runtime, Node application, like JavaScript application, Node runtime, or different runtimes, and the data which supports your application and the application itself. So you need all these resources if you want to run an application. So what happens in a traditional IT form is like traditional. If you want to run your application traditional way, you have to bring all these resources yourself, and you have to maintain all these things or configure all these things, like all the layers up to the application down from network. These has to be configured by yourself, and those has to be maintained by yourself. But this is a time consuming thing. And coming to the time, like let's say I have written a code like to run just a hello world program in Node.js, like JavaScript, and it's running in the Node.js. And if I want to run this application, I need to do all the steps from networking to the data. If I have to have a data on this, in this example, we don't have any data, but just to give a hello world application. So anyways, I need all this server things to be set up before I need to run my application. And if application grows, the application which is going to be deployed, if that grows, the management on the storages need to be increased, and managing between these storages and the run times will be a hectic one. And traditionally from the analysis, to bring up an application, it takes weeks of time. Like after completing your code and to run your code and make it available for the public, it will take weeks of time, at least a week for a smaller application. So this is the main reason why cloud computing has become a very important technology these days. With this, with the cloud computing, we can take advantage of 3 different services which I have told before: infrastructure as a service, platform as a service, and software as a service. Based on the nature of the service, we can take some of the layers from this infrastructure, like from this stack, to somebody else who delivers us the service, who delivers those things as a service for us. So let's say infrastructure as a service. Infrastructure as a service, the below 5 layers up to operating system, we can lend an operating system, Linux or Windows or any other Linux system flavors. So we can lend them, and on top of that, we can just run our runtime. Like if I want to run a Node.js application, I just want to have a Node.js on that, and then just run my application like Hello World program on that, just that. So it will decrease my operating like my cost to buy all these things and manage all these things. This is an infrastructure, like from up to networking to up to operating system is lent by somebody else. This is called as infrastructure as a service. If I want to run the same application like Hello World Node.js application and just want to I only have a code like code base. I don't want to manage everything else, nothing else. So that's where platform as a service comes into picture, saying that they'll provide you operating system, like networking to operating system, and also runtime. Runtime meaning if I want to run a Java application, Java runtime, Node application, Node runtime. So these layers are provided by somebody else, and I'll just push my code or deploy my code onto that runtime. And this deployment will take, based on the size of a code base, it will take minutes to like only seconds to minutes of time, like maximum 30 minutes of time, other than max of 30 minutes. And then in 30 minutes, your application will be up and running, and it is available for the cloud, like public usage. These are the three different services, three different like traditional infrastructure and a platform where we'll engage some of the resources from our side, like as a user or a deployment or a business, and some of the resources are lent by somebody else will render us. So these things, and here after this, let's talk about software as a service. Software as a service is like if I want to have my like employee management as a business, if I want to manage your employee details, like I have 100 to 200 employees in my organization. I want to manage all the details of my employees. And if I want to build an application as an organization, and I have to build and I have to write an application code for that, I have to maintain it data, and I have to run all whether it's my choice that I can lend all the runtimes to networking these layers, or I can build my own. So, but there are some softwares available in market. They do all the services like employee management. They can store my employers details. They can store leaves of my employees, or all the related like tax details or pay scale details. I just can, as an organization, I just can lend their services. This is as a software as a service. Here, the main important thing of software as a service is like I'll pay as a subscription model. Like if I want to use 3 months, I can buy a 3-month subscription. If I want to use for a 1 month or 1 year subscription, I can buy. So by this, I can only pay for the usage, not for the infrastructure, not for the code. And with the help of software as a service, as an organization, I am not in a need of writing an application which is already implemented. There is no need of reinventing the wheel again. And as software as a service, applications are like applications which are in the market are well grown, and they provide much more features than which I like. If I want to have a application built myself, it would be time taking for me, and maybe the features are very less or very more. But applications which are in market, they can grow and sync, and they are matured enough. These are the different different service models which cloud computing provides. And I'll just share the different examples of different service models. So IaaS and platform as a service, infrastructure as a service, and service as a service is the three main service models. But this FaaS and DaaS and STaaS are like combination of let's take a DaaS is the only, like these are the more molecular level divisions, but we can only consider IaaS as a service and like platform as a service and software as a service. Let's take Amazon as an example. So infrastructure as a service, in Amazon works, AWS works as infrastructure as a service as well as platform as a service. what's the difference between infrastructure as a service and platform as a service? So infrastructure as a service, if I want to have just a EC2 instance, like a operating system, like if I want to run an operating system of Linux, and it just give a bare machine of only installing operating system of Linux flavor, and it will give us, which is called as EC2 instance in the Amazon terms. And if I consider same Amazon in the platform as service, Amazon provides a platform where I can build, where I can, like if I have a code application, I can give the code or a code base to the Amazon. It will deploy, and just I can say what runtime I want, like a Node or a Java. I can just say this is a runtime I want, and this is a flavor of operating system I want to install this on. So it will install all of them. But when compared to the EC2, like IaaS EC2 instance, I'll take an EC2 instance, and on top of that EC2 instance, I'll install runtime Java or Node, and then I'll install my run by application. Here, I just need to give an application to the platform as a service which Amazon provides or any cloud provider provides. That's it. And all the managements will be done by Amazon, and we pay for the cost which we use, like minutes we use, or the resources we use, or the size we use. And next we'll go with the deployment models. And with the cloud, like let's say with the cloud, the security is the main issue with the cloud computing. So cloud computing also provides 3 different models of deployments. If I want to deploy my application, there are 3 different ways I can deploy my application, which is like 3 different ways are like cloud, hybrid, and on-premise. Cloud is like I can deploy my application to the let's say example of Amazon. I'll give an code to the Amazon, and I don't preferably say that this instance or this region or this one. I'll just give my code and just deploy to the cloud, and I have no control on where my application is sitting, like region or resources. This is a pure cloud. And hybrid, like we'll go for the next on-premise, and then we'll go with hybrid. On-premise is that I'll, like when I want to apply, like if an application is a sensitive application, so I'll go and I'll take advantage of AWS or a cloud provider. But I'll ask them to have a separate VPC, like virtual network for me as an organization. So it will install only to that organization, which is securely bonded by VPC, like virtual private network security controls, which is like there is no difference between on-premise and cloud other than security constraints they hold. And hybrid is like, if I, like as an organization, if I have a lot of applications, and some of the applications hold sensitive data and some of them are like public, so I can hold, like on-premise is like they'll come with the security details, so security inbuilt, so they cost much, and cloud is like much cheaper than the on-premise. That's why, like if I have to maintain my cost, I can build my security like secured applications in the on-premise cloud and other applications in the cloud, so that I can balance my cost as well. So this is a mix of cloud and on-premise, is the hybrid deployment model. Yeah. So if you have any doubts, please, is that clear? Or if you have any doubts, please let me know. Otherwise, we can go for the next slide. Okay, then we'll go for the benefits of cloud computing. So with the cloud computing, the main and the foremost important thing is the cost reduction, and where we don't have to invest on the money, like initial investments on servers or the database management or anything else. And we just go on to like, if I have an idea of building an application, just I will go and build my application with the features which I want to have, and then that's a main reason a startup can, like, that helps any idea to build into an application format. And then other thing is stop guessing a capacity. increasing the speed and agility of an organization, like, or an application or organization. Let's say if I want, like, what I meant by this is like, if I don't want to waste my time on building my infrastructure at the first hand, I can bring up a different features in the same point of time. I can bring in a feature or a feature which helps in my business. Like, I can, with the different features in the same point of time, I can earn some money or it's a business in, and performance will be increased and productivity of application is increased, because as the cloud computing is increasing, there are a lot of technologies in the industry which helps us in using components which are already built, reusable components. So that by using reusable components, we can just use the components which are already available and increase our productivity rather than writing those components by ourselves. And the scalability and elasticity. This is also a second major important benefit of cloud computing. Like let's say this time, like let's say in some point of time, if my API my application has become famous, and that if I want to maintain the request, I have to increase my number of servers. If my application is hosted traditionally, then I have to do whatever, like I have to bring up a new server, new database, and all those things. That is like, it will take days of time. If I use cloud computing technologies, I can spin off new servers or new databases in seconds of time. And if I want to, like, in today the business is in India, and if I want to move my business to any other states or any other continent or different spheres of the world, then I have to host my servers or the databases in different parts of the world. Then physically somebody have to install the dependencies or the servers there to have less latency in the request. So that will be very easily solved by the cloud computing. Let's say I have to host in a US region, like Virginia or anything else, Oreo or some regions. Then I'll just spin up a server, the same server which is hosted with the same configuration, just a region specification with different configurations, saying that this has to be hosted in different region and following the different security concerns of that specific region. So so the scalability and elasticity is enhanced, or we can manage these things easily. And other benefit is, like, I just go through the 3 different benefits in more details. So as an organization grows, like if an organization starts with an application 1 and it grows as a business extends or they become famous, they add different applications to their infrastructure. So let's say they have a different applications, like hundreds of applications, and as an organization they have to maintain those organizations. And most importantly is like the human resource, the person who has built the application, they have to maintain them, and maintenance is a very big cost for them when, like, application grows or number of application grows. If I have to put this, like, when I migrate these things to cloud and everything is away from and somebody else will manage, I just pay the cost for it management. And so as I speak earlier, like elastic capacity. So these are the different graphs which shows how we can reduce the wastage of resources. Let's say this is on and off, like as a traditionally, when I say I have bought a server for specific configurations, and in the graph on the left top, so this configuration will remain as is, because I have configured and I am maintaining for the servers, and I already bought all the servers of specific configuration. So if I want to shut down my business for some time or reduce the bandwidth, I cannot do that because I already invested money there. So this is a peak usage, and if some usage is very less, these are the script lines are like wastage. And if organization is growing, and I expect my organization growth, like from this point of time to next 6 months, with that growth in my mind, I'll buy my all servers or the resources which I need infrastructure. So I buy these resources, which is the graph which is showing on top right. So I buy these resources, and but in some point after that point of time, if my business is growing much faster than the expected rate, then I have to like expected rate, then I have to bring my service, like I have to double the let's say if I have to double the resources, I'll double them, but the usage is very less than the increment of the usage is very less than the increment of the resources. So these script lines are resources wastage, and they cost very much for the organization. And if a usage of a application is this way, like spikes, ups and downs, then the others ups and downs, the remaining time, the resources will be in a an unused state. So because of this wastage, most of the organizations are moving towards the cloud deployments. So cloud deployments, because they can grow or shrink their resources according to the usage. So, and because of that, there is no much pressure on the business because of the cost. Yeah. So then we can go for we'll just talk about the cloud providers. As cloud computing has become very interesting technology these days, there are a lot of cloud providers. Just to list down: Amazon Web Services and Google Cloud Platform, Microsoft Azure, and DigitalOcean and VMware. And this is not an exhaustive list, and there are a lot of other cloud providers as well. But we can choose based on the use case which we are going to solve. Like if somebody is providing the same resources with the same resource, if they are providing same resources with the cost, like lesser cost, or with different features, or if they are providing managing resources easily, or if they are secure enough, we can choose based on the criteria where my application want to run. Like if a cost is very important, we can choose accordingly. If a security is important, or if availability of a resource is important, based on that we can choose the cloud providers. And then we'll just talk about the AWS as in details. And the demo which I was going to do is very basic demo, where I'll show different resources of the services AWS providers and how to spin down and how to spin down and maintain logs of things. Yeah. What is AWS and why AWS is very famous compared to other cloud providers? So AWS has started their web services, these resources, EC2 instances or any other resources they provide in 2006, which made cloud computing a very famous. Before, cloud computing is a science which already exists, but with the launch of AWS web services, cloud computing has become very famous. And AWS helps to reduce total cost of ownership. The one which I was saying before, infrastructure cost or maintenance cost will be reduced, and we'll pay to the resources we use. When we use them, we'll pay them. Otherwise, we don't pay them. So there are a lot of cloud computing resources they provide, coming from storage, computing system, and databases, and tools to manage the resources. In the storage, there are three famous resources they provide: Amazon S3, Amazon Glacier, and Amazon Elastic Beanstalk. And then these resources like Amazon S3 or Glacier, they give 11 nines of durability. This is the percentage of durability they give us. Durability in the meaning 99.99% of times the resources will be available. There won't be any damage or loss of resources, loss of data which we store in S3 or Glacier. And then comes the computing system. They have EC2 instance, Elastic system, cloud computing, and then high performing databases like RDS. They support both relational and non-relational databases. like RDS, Elastic Cache, and DynamoDB and Redshift, and it provides hundreds of services. And to use the like any application use multiple of services Amazon provides, and maintenance of these resources is a headache basically. So they also provide many maintaining services, managing services here, like CloudWatch, IAM, and CloudFormation and Elastic Beanstalk. CloudWatch is like if my resource, let's say I have a EC2 instance which is running in the AWS, and I want to trigger, like alert my business or alert myself when EC2 instance usage is grown, like more usage is more than 90% or more than 80%, so that I can spin up my other instance. Then I can run CloudWatches. I can build a CloudWatch on the EC2 instance saying that please trigger a event or a notification if my EC2 instance usage is more than 80%. Then it can notify me to the email address specified or any other person. This is the CloudWatch. We can trigger, using the CloudWatch, we can trigger notifications. And IAM is the most important feature which AWS provides, based on like as a cloud, like as the resources are not in our hand management, in our hand, or we are not managing them, the security is the most basic or most important feature which every AWS resource has to be adhered with. So IAM is like will define different users and different roles a user can like, and different policies or permissions to a user, so that a user can do only those activities which pertain to the permissions. Likewise, if I can give a person, he can only read or write. I can give an administrator all the read and write operations. I can give a normal user only read permission, so that there won't be any hacks or any unexpected incidents happen. And CloudFormation is also important one. Like let's say if I want to run, like I'm running a EC2 instance in the Indian region, like Mumbai is the region, and then if I want to run the same instance, EC2 instance, like with the same configuration, I mean, if I want to run the same instance in different region, I have to write all the configurations. That I'll open the AWS console and write all the configurations and spin up the EC2 instance. Yeah, it is an easy operation, but somebody has to manually do those configurations and spin up the instance, which takes like minutes of time. But we have to hold the informations, like this is a configuration, this is a runtime we use, this is operating system, or this is a size we want to spin up. So with the CloudFormation, we just write a script in a JS or JSON format. We just run the script of configuration. If I want to run an EC2 instance, I'll just note down the configurations of specific EC2 instance, and that will be stored in the CloudFormation. With the help of CloudFormation, we can run the JS file multiple times. It will install in multiple locations, or it will spin up the multiple EC2 instances in the same region. And next comes the Elastic Beanstalk. Beanstalk is like it's like a platform. Like I already said that AWS works as a platform as a service and infrastructure as a service. So infrastructure as a service is like it provides a bare machine like EC2 instance. If I consider a platform as service, Elastic Beanstalk is a platform as service example, because the example which we took earlier, like I want to run a Hello World Node.js application, I just gave that Node.js application to the Elastic Beanstalk, and it will run, and I can configure how much availability or how many regions in how many regions I want to run this application, and how many, like what is the size of your database or what type of database and what is the runtime, and just specify those configurations. And Elastic Beanstalk will take my code base and just it installs, and within minutes of time, the code will be like application will be up and running. And then comes the global infrastructure of AWS. Like there are different terminologies AWS uses, like regions, availability zones. So region is like, I'll show a different screen of AWS documentation. So you can see my screen, right? Of other than the presentation. Hello.
Yes, ma'am, we can see.
Yeah. So, like, according to the global infrastructure, so 24, there are 24 launched regions, and each region has some availability zone in it. So there are 76 of availability zones, and if I open regions of Asia Pacific, Mumbai is a region. Yeah, Asia Pacific. Mumbai is a region which has 3 availability zones, and this has come up in 2016. And this list is growing as of now because they are extending their services, and to increase their regions is very easy task because they have all infrastructure ready. They just need to dump their resources or move their services to some other regions. And we'll go for the next slides. Yeah. So the main concern, like if a business want to move to the traditional on-premise architecture to the cloud architecture, main concern will be cost and the security, as resources as the resources cost is very less. Like security is a major concern other than the cost. So AWS provides security of the cloud, but by practicing best practices or softwares which use as a best at their best level, we have to, like as a user or organization which lends the AWS services, have to maintain a security in the cloud, because AWS, while AWS manages security of the cloud, it is our responsibility that we'll maintain the security in the cloud. And so next comes the AWS Universe. Like what I mean by this is, like if I want to run an application, what are the different types I can use AWS services. One is Web Console, which is very famous one, where we log into the Web Console, like website, and do all the configuration and spin up the services, or upload our application, or we can build storages. And other thing is like SDK, software development kit. So where AWS provides SDKs also, like based on the Java SDKs or JavaScript and any SDKs, we can download their SDKs and use their APIs to spin up the applications, spin up the resources. And they also have a vast set of APIs. And their command line tool is also very famous, CLI, AWS CLI, where we can do all the things from the command line. And we'll go for the demo, and we'll just AWS. Yeah. So this is the AWS console, and these are the different list of services they provide us, like computing. In the computing area or a category, EC2, Lightscale, Lambda or Batch, and Elastic Beanstalk, which I was talking before. And they also have analytics and blockchain, and the storage. Like storage, they have S3, EFS, and a Glacier. And other important thing is IAM as a service. Yeah, IAM as a service, like security, identity, and compliances, IAM as a service. And they also provide game development and machine learning as well. Yeah, AR, VR, machine learning. We have SageMaker, Code Guru. So we'll go through the EC2 instance, how we can spin up a EC2 instance. So this is just a console which specifies how many EC2 instances are running, and what is the volumes you are using. And this is just a glance. And if you see on my left, right top, this is a region where I am connecting. This US East is a region, and N Virginia is a availability zone. And in the Asia Pacific, Yes, Mumbai. Where is Mumbai? Where is Mumbai? Okay, I could not find Mumbai region. Yeah. So now I am on US East and North Virginia. So if I want to launch a instance, EC2 instance, launch a instance, and I can choose. There are a lot of images and flavors. Like if I want to Windows operating system or the Linux flavors or any Linux flavors, I mean. And so this is like my account is in a free tier. Like if I like if I sign up for the Amazon, it will give 12 months of free tier. Now present account is in a free tier, and it will also show me like which is eligible for free tiers. I can only select those instances of free tier eligibility, and these are the images which already available. I can also upload my image. Like if I have a specific operating system with specific softwares installed on it, I can also upload my images and use them. There are also a AWS marketplace where I can buy whatever the softwares I want to use. So I'll quickly select one of them. So this will the flow or the workflow, which it will allow me to configure EC2 instance with storage and all the configuration and security and all those things I can configure in the workflow. So here, general purpose and T2 micro. T2 micro is there are different sizes of a server I can choose. T2 micro is the smallest, like nano is the smallest one, and micro is next to it, and small and large, and X large. And price of each server will increase based on the size we choose or type we choose. And like this nano or a micro or a small indicates how many CPUs and how many memory they hold, how much memory they hold. And I'll choose this one, which is eligible for free tier. And I can launch this EC2 instance as of now, but because it will give all the configurations it will take all the default configurations and it will launch, but I'll just go through what configurations a EC2 instance hold. So these are the different EC2, I can give number of instances I can run, like auto scale or I can just say one instance or two instance now, or I can run a auto scaling group. Like if I say based on if I want to run my EC2 instances or increase my EC2 instance based on the request rate or number of requests, then I can launch a auto scaling group where they automatically scale down or scale up based on the bandwidth or the number of requests. And these are the different different network and subnetwork IPs which they get enabled to EC2 instance. And the IAM role is the IAM, what IAM role we want to assign to this EC2 instance, so that the persons or the users which has that particular IAM role will only be those people can only access that instance. Other than that, we cannot. So somebody else cannot access that EC2 instance, which is a security. Yeah, and next, add storage. I can also increase or decrease the storage size. As of now, 8 is a default storage type, and I can also choose storage volume type as well, SSD or magnetic or IOPS. And next, these are the just tags which help. If I have a multiple EC2 instance and I want to run or stop some instance based on the region or based on some tags, I just give that instance key or a tag, so that it is helpful while we filter out instances. And next comes the security group. Security group is who can enter or who can access the EC2 instance. I'm by default we are only enabling SSH permissions to the EC2 instance, and the IP addresses are configured as 000, which is by everybody from SSH can access this instance. We can just launch an instance. And this, we just review what are the configurations we added, and then launch. Because as we have chosen the SSH permissions, it will create the SSH keys for me. I'll give a name. This key pair will help me to SSH into the instance, because we only allow SSH role into the EC2 instance. Launch. Launch. So if I go to EC2 instance dashboard, my running instances are 0. I'll go to running instances. It will take some time to come up. And this is like, what is the instance type, instance ID we get, and what is the type of instance, and where the instance is hosted or available, the availability zone where this instance has been hosted, and the status. It will take a few minutes to come up. And the public DNS. And these are the different types of configurations or the properties a instance holds. Like the state is pending till now, and the micro. And this is the IP, private IP, with which I can log into the, like before this, I just downloaded the SSH PEM. Then using this private IP and SSH keys, I can SSH into this instance. Yeah, this is how a EC2 instance is configured. And the next important resource AWS provide is like a S3 storage. So S3 is like a drive or a storage system where we can store any type or any number of, like any amount of data. So this, we can create a bucket here. In here, they call a category or a drive as a bucket. Bucket name should be, this bucket name is publicly available. Like we can fetch this, we can request or fetch this bucket publicly. So this bucket name has to be unique. Must be unique. I'll just give. Hopefully this is available. And I can choose where this bucket has to be hosted, in which region. Yeah, like based on block all public access, by default it is enabled. If I want to disable so that I can access from the outside region, and I can create a bucket. Yeah, this is a bucket. So this is just like a drive where I can upload or upload files, store files. And the S3 bucket is mainly used for storing your code base. Generally the format is like S3 holds number, like your code base, and from the code base there are some other plugins which fetch code from the S3 bucket, and then they'll deploy the code into the other environment or other resources which AWS provide us. Just a simple S3 bucket configuration. And then next, RDS. RDS is like a relation database, and it supports multiple options like NoSQL and a SQL databases as well. And when it comes to the RDS, it's a paid service. So I just go through the different configuration a RDS holds, but I don't launch them because it costs me. So just we'll see what different types or different configuration a RDS hold. So I can choose engine options, like if I want to run my Amazon Aurora or a MySQL database or Oracle database any type, or Postgres. So, and which region I want to host on, if I host my service, which region I want to host this database on. And hosting a database to specific region helps us in retrieving, latency will be depending on the database host region. When an application is running in some region and the database is in a different region, the host latency of a network call will be high. So that's why people prefer to host their database and application in the same region, and the same architect, like the same copy of these things will be replicated in the different region as well, so that the data will be up to date, and then the latency of the request will be less. And so we can also choose how modifications to a database can be done, like one writer and multiple reader, which this is the most, like this is a very efficient one, because there won't be any unsynced data, because somebody, only one person or one request will be writing and multiple readers will be there. If this was the other case, other round, like multiple writers and multiple readers, so there will be a chances of getting data getting a stale data. Yeah. And we can choose like production or a dev test. So what is the difference between production and dev test is like some of like the reliability and the fastness of a database server will be changed. Other than that, the properties of a database server will be as is, but the time to fetch the details or get records from the database will be different, because if in the dev or test environment we can hope for a request, we can hold a request for more time, but not in a production. And like we can also specify, like if I want to run a database in a cluster mode or a single server, like if I want, based on the request or the bandwidth or the number of requests I expect, I can choose if I want to have a cluster or a single server, like single database server. So, and these are the just credentials or the managed security things to the database. And I can also choose what is the size of a DB instance and availability of a DB instance. Do you want to have a replicas or we don't want to have a replicas? Replicas is like the replicas hold same data of a like there will be a one master server and there will be multiple replicas. Master server will hold absolutely latest data, and replicas will hold like data which is similar to the master, but the data will be always synced from master to the replicas, so that replicas will hold backup and also serve different regions. And also we can specify to which VPC this RDS has to be, like this database server has to be linked with. So when I create a AWS account, there will be a VPC already created, virtual private cloud for an account. So this is a default VPC which has been created to my account, and by default we can assign my RDS instance to this VPC. And there are a couple of other authentications, and then we can create and it will take few minutes to come up. Yeah. These are three different types, RDS and S3 and EC2 instance, which we are using. Like the main resources we generally use in AWS. And I'll also show like a sample application using Elastic Beanstalk. So as of like we saw three different types of resources like EC2, S3, and RDS. Those are like infrastructures provided to me. Like I can choose an infrastructure size of an instance or size of an RDS, or what type of an RDS I can choose. I can choose them, but this making like running a EC2 instance or configuring S3 or spinning up an RDS server does not make my application run. I have to deploy my code, and I have to write all the linkages between all these three resources, and then spin up the server. Like then comes my application into live, and which is accessible to the public. And these resources are examples of IaaS, infrastructure as a service, and there are some extra management I have to do as a user on top of this. But I'll also go through the Elastic Beanstalk, which is like they provide as a platform where you just need to provide your code, then it's up. It will be taking 2 or 3 minutes to come up, and everything will be working. So I'll take an example of like as of now I don't have any environments or any application. What is environment? Environment is like I can have a test environment, I can have a dev environment, or I can have a production environment. And applications are like I can run multiple applications. Like I can run a web server, I can run a like backend, like backend server or something, which, so this applications will have, like, according to the business, there will be a set of applications which are running in an environment. Like I can run a set of applications in tester environment, I can run the same applications in production environment. So I'll just go through the steps we want to have. Just we want to spin up a application, getting started. Okay, so these are the different steps to run a getting started app from the Elastic Beanstalk. Actually, this helps, like if we don't have anything, like if you don't have knowledge of EC2 instance or any AWS instances, we just have a code, and I want to, like, this is like test and tier up, tier down based on your test, or if you want to have any like testing. So based on that, I'll just take a getting started app which is already provided by the AWS. I'll spin up those things and let's see what resources this getting started app will provide us. Application name and a key if you want to give. This is an optional one, I'm not giving, and a platform. So these are the different platforms I was running, runtimes of the platforms I was talking about earlier. So I can use any of the platforms here. Like if you want to run your Java application on Tomcat server, or a JavaScript application on Node.js, or a Python application or Ruby application. And so I'll start a Node.js application, and I can also choose whatever, like operating systems. These are the different operating systems are available, like Node.js, Node version 12.10, and the corresponding operating system like 64-bit Amazon Linux too. I'll choose Node.js 12 latest version, and platform version, and a sample application. If you want to use your code to be deployed, this is a source file we can upload. Or as I was mentioning before, generally people use as S3 as a code-based server, like storage. So local file, or if we have a local file I can upload, or if you have an S3 code base is already uploaded to S3, I can use S3 as a S3 URL as well here. I'll just go with the sample application provided. So configure more options. We'll see what configurations we have. So databases, tags, and notifications, I don't want to like do any of them, just a bare Node.js application. Create an app. It will take some time, and we'll see what resources it will spin up. So AWS S3 is being created. If I go to the S3 page, okay, I should see one more. It will take some time. We'll see. Creating Elasticsearch. Oh, sorry. It is using my existing because I'm on the same, like, so I'm running on US East 1, and there is already existing what do you say, this S3 bucket, so it is using same S3 bucket. Elastic Bean US East 1, and this is the bucket it is using. And it also configured security groups. If I go to home, I can see what are security groups. So earlier there were, like, by default we'll have one security group. So as of now, the two security groups have been installed by the Elastic Bean Getting app. So these are the two different security groups. If I open a security group, these are the rules, like with the HTTP. Like earlier when we were launching a EC2 instance, we just allowed only SSH connections to the EC2 instance. Now by default, the HTTP connections over 80 port is allowed from any IP address. So all the requests for the 80 port will be served. Other than any request for the other than 80 port won't be served by this server. And if I go to other security groups, like there is also a security group attached for the SSH connections. Like SSH connections are mainly used for debugging. So when we say that a specific instance, like when we get some errors while handling a request, or if we want to see some logs or different storages, or if I want to clean some unnecessary files or stacked files, I can SSH into the instance which is running using their public and private IPs, and the PEM which we PEM. So we can SSH into the server and we can delete or we can manage the resources accordingly. This is a security group for SSH connections, and the other one was for HTTP connections. And this is a default as a security group which is assigned when I create my AWS account. Yeah, other than that, we'll go to the EC2 console. So there are two instances running. Because one was like earlier I have started a EC2 instance, and this is a EC2 instance getting started is a EC2 instance which run by Elastic Bean. So this is how, like, it has created security groups for me. It has created EC2 instance. Like I did not invest my time or my energy in creating all these things. It has created itself. I just gave my code to that and it just created everything. So I'll just go and access Elastic Bean resource, what application it has started. The health of the application is, the environment is okay, and I can access this application which was running here. This is the application which has started getting started app with the help of Elastic Bean stack. This just a web console where they'll route each link to the documentation of AWS. Yeah, so that is a tour and a little of demo on AWS resources, and I'll make sure that resources are, like, please make sure if you're trying, make sure that the resources are deleted, otherwise we should be paying for them. And any questions? Anybody? So if you don't have questions, thank you for joining.